This is a demo of using Entodicton to make a D&D kind of app. My daughter had a boyfriend once that did LARPing, and I asked what that was, and they said live action role play. So then I thought it was funny to call D&D Parping, pretend action role play. Yeah, so what we're going to do first is I'll just copy the tutorial, one of the tutorial files. And set it up to point to my deployment. Oh, so the app's going to be like, it'll be a D&D app. There'll be rooms and monsters and players and that kind of stuff. Yeah, so I'll copy the server name over here and then get the key. Give it a run, make sure it's hooked up right. Oh, it runs slow because it's training the neural networks. It'll cache the training, so it'll be faster on subsequent runs as long as you don't change the config. Okay, so now we'll set up our app. So I made some data that has players in it, so we'll load that. Okay, so there's player, Bilbo, Aragon, or whatever. That could be our data. It can be in a database, right? This is all on the client side, like on the node side, not the server side, which is Python. So we'll maybe start with the first sentence will be like, who are the players? We'll just start with that, and I'll give a demo of how to set up Entodicton for that. So Entodicton is a generalization based on a generalization of the operator precedence parser, which is normally used to process arithmetic expressions, like 1 plus 2. So in that, plus is the operator, and 1 and 2 are the operands. Yeah, 2 plus is an infix operator. 1 and 2 are the operands. So in this sentence, R is like the infix operator, and who and the players are like the operands. So we're really parsing like English now, like it's an expression. So in this, and the actually acts like a prefix operator, like -1 in that arithmetic expression. So if you're to parse it with an operator expression parser, plus is infix, minus is prefix. Just like in this sentence, we're going to mark it so it knows that the is a prefix, the operands are who and player, and R is an infix. So you mark operators with these braces. So I'm marking who and players as operators because it's a way to get a type into the system. Like to have a type system, you don't have to do that, and the operands will be untyped. Okay, so now I'm going to mark the as the operator. It's going to be a prefix operator, so we have to have some way of telling it of knowing it's a prefix operator. So I'm going to scope it so I know the and players is an expression. Now I need to mark the as the prefix operator, and I do that by taking all the operands and putting parentheses around them so that I know the is the actual operator and all the other stuff in that scope is the operands. So we'll just do the same thing with R. That's going to be an infix operator. So I have to mark who as an operand and then scope the whole thing, the infix operator, so I know what are the operands applying to R. So then that gives us our definitions. So we've defined operators and their arity and what type of operator they are. So let's give it a run. I forgot to delete that. Let's get rid of that example. Okay, so run it again. I don't know. Oh, my laptop has a bad network connection. I haven't got around to fixing it. Okay, so here's the error. So we didn't define the bridges. So the way this works is it takes a sentence, and each word in the sentence, it converts it to what I call a context, which is really a property bag that has some other stuff. Each context has a marker that is the operator. And so bridges are used to tell code how to take a collection of contexts that are being applied in the expression and map them to a new context. So I was sort of thinking of the context like little islands, and the bridge tells you how to go from one island to the next island. So the error message was saying we haven't defined how essentially the semantics of the operators. We haven't defined how to do that for the operators we just created. So I'm going to do that for who and the players. So they're kind of they're operator that takes no operands. So zero on both sides. So we'll define who and the players. So I'm just going to copy what I do for the other ones from the demo. And so this will give us the bridges for who and players. So now I know if I see the context with the operator who, I know how to use a bridge to get to the next level of the operator. In my extended operator precedence, generalized operator precedence, operators can evaluate to other operators. Oh, this is when you mark the operators, like the word the maps to the operator name the. So you can use this bar thing if you want to give your operators a different name than the words that are mapped to it. So for player, I'm going to call the operator player concept. And then the word players maps to that. You can have a list of words there too if you want. There's also a words section in this whole config you can do stuff in. Okay, so I'm going to define that's a prefix operator. So I copied the every, and which is every car. It's like a prefix operator. So I just copied that. I forget how I implement the. Let's see, how did I implement the? I don't know, I forget. So let's just go look at the demo config that I have, and I can just do that. So if I forget how to do stuff, I'll just look it up here. So this repo is public, so you can just sync it if you want. Okay, so let's look at how did I implement in this thing? Oh, so in the bridge is actually run in Python. I have my own parser and I make it look like JavaScript. So you have spread, you can access arrays and do the property notation and create new contexts. But it's technically not JavaScript here. It just looks like JavaScript. So what we're going to do is the same thing. I'm going to do spread the after. So there's 3 keywords available. There's after, before, and operator. After are the args after the operator, before the args before the operator. I'm just going to mark with pull from context instead of what I did concept equals true in the other one, because I started to do this for implementing it and probably they and other things like that. So I'll just do that in anticipation. I'm going to do something like that. So now let's define the bridge for the operator R, except we're going to call it to be and have the word R mapped to that operator. So I'll set that up. Yeah, so we're going to do, I'm just going to use the spread and pull the operator. So that just takes the current values. So the marker is the thing that is the operator. Whatever property is called marker, that's the operator that's going to be run. I'm going to make 2 new properties, before and or subject and object. I'm going to set that to before and after. We can make this fancier later, right? We're just getting going. Let's give it a run. Oh, I got to change the sentence to be the sentence I want, not the sentence from the demo. Who are the players? Now let's give it a run. And again, it's slow because of the compiling the neural net thing. Oh, I forgot I changed the name of the operator from players to player concept. So I got to fix the bridge definition because otherwise it says there is no bridge. I tried to put in good error messages because whenever I had to debug something to figure it out, I added an error message. So I didn't have to debug anything. So hopefully I have good error messages. Okay, so it ran. So now we can see the output. Currently, I'm just printing the generators, which is the generators. The system takes the JSON that's created and converts it into a string in a language. But I don't have anything defined, so the generator is just taking all the JSON and stringifying the JSON. So that's kind of boring. So let's take a look at the actual JSON that's returned from the server. That's in the results field. So look at that. And yeah, so now you can see the JSON that hasn't been stringified, and that stuff with the strings above is just the stringification of the JSON. We're going to fix it so it prints out English. And you can see there the player, the was applied to the player concept. We can't really tell what's going on here, so I'm going to add tracing so we can see the list of context and see them as the bridges are applied, and it generates new context. Ultimately getting the correct answer. It's not currently doing that. So turn on debug. Now we'll see what's happening here. Oh, I think it's retraining because debug was set, so we'll have to fix that because that shouldn't retrain. Anyway, so you can see here, it starts out with a list of contexts, one for each word. I printed out in kind of YAML format. The contexts all have a marker. The marker is the operator of the context, and then the other properties are whatever you want. The /0 is the level of the operator. Applying an operator creates a new operator one level higher. So here you can see it selected the operator player concept, applied it. It has no args. Created the next. This is how typing gets in. Then it selected the operator applied that, and you can see it did what we said in the bridge. It spread the operator, the player concept operator, and then added that pull from context property. Now it's applied the who operator, and then finally gets here, and the to be operator is dead, so that means it didn't apply. So like, why didn't it apply? So let's figure out why it didn't apply. So this is a little Pythonic, but an operator has this part of here, the 0 and the 0 is operands to the left and operand to the right, and they're basically untyped. So how many operands to the left? 0. How many operands to the right? 0. This other section is the typed one. Typed operator to the left and typed operator to the right, and we can see it has the who on the left, which looks like it matches the number 0 context, but the doesn't match what we have in the number 2 context. We want it to be of type player. So we have to fix the operator definition because it's wrong, and that's why it didn't apply. So we'll go over here. Okay, so we'll go fix the definition. So when we mark the as an operator, we use the square braces. And that's just a normal operator. So it means the result of applying the operator is of type the operator for next level. So -1. And that's the problem. So there's this marking we can use to say it's a pass-through operator, which is greater than or less than and greater than. And then that will mean the result of applying the operator is not of type the same operator next level. It doesn't go from the1 to the2. Instead, the type is going to be the operand. Yeah, so instead the type of the player is now going to be a player concept, and really is just adding sort of annotations to the player concept context. So now let's give that a run, and we should see that the to be is defined differently, and now it will apply correctly, and we'll get the JSON we want out of this thing. Okay, so now we can see it applied, right? If we go here when it selected the to be 0 operator, yeah, we selected the to be 0 operator up here, we applied it, and we got a new context where it's combined the operands, the player and who, with the operator to produce, subject and object. Those are just arbitrary names. And then finally it tried to apply it again and got the dead, and so then it knew it was done processing the input. I'm just going to delete some of this other junk from the demo so it'll compile faster. I don't want to see any of that. Okay. There. So now let's give it a run to make sure I didn't break anything. Yay, I didn't break anything. So now we'll work on the generators. So when it gets the results, which is a bunch of JSON, it runs the generators after that. And the generators convert the results into a user-readable string. So right now you can see it's just, this junk is just, the user-readable string is the the JSON stringified into JSON. So we want to make that instead print out stuff in the language. And if from the demos you can see it can do multiple languages and stuff like that. I'll just tag that so we can see it. Okay, so let's work on the generator. So generator, it traverses all the context in the results, and you have a sort of a selector that is used to select which context to use. The generators are not ordered, so the contexts have to be like actually selecting the exact one you want. Otherwise, it'll just, if multiple context generators match, it'll just randomly pick one. I need that because there's a way to include knowledge modules and there's no way to specify the ordering. So what we're going to do is take and make a string out of the context. So the string is going to be this G function here in the first part where I applied it. That actually runs the generator again on the context. So that's important to do. Otherwise, it doesn't run the generator on the context. It'll just stringify the JSON. So we can see here now the string generator is looking more like what we want. Now we have subject as JSON, blah, R. So now let's set up a generator for who. So in the context, the tokenizer will shove a property in, which is the word that's pulled from the sentence. So I usually just use that again. It seems to work a lot of times. We can just use that and you don't even have to do any fancy stuff. So I'm just going to use the word. And so now when it sees the context with the marker who, it should print out who. And this is just getting going, so I'm not making it very sophisticated. We'll do that later. And so now we'll just do the same thing with the players. So the player concept. So if we see a context with the marker player concept, what are we going to do? We're going to do the, and then I'm just going to do the word again. So now we run it. It didn't work. Why didn't it work? Why is it printing out object? There must be a reason. Okay, what am I doing wrong? Definitely not working. It's good to have errors in demo, then people see what the errors are and then they correct them. I don't like demos that are perfect because then you just see how everything works and you get an error and then you have trouble debugging what it is because you have no intuition. So this is good. It's generating your intuition. Let me just check what's getting returned. Yeah, that looks correct. So why is it not picking up? Why is it not running the generator on the player context? Let me take a look at this again. Da 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 da. And a back. I forgot to call the G function. Oh wait, sorry. Let's stringify this and make sure, you can use this to debug the, what's going on. Oh no, wait, I discovered. Okay, so I didn't use the G function, that's right. So since I didn't call the G function, it just stringified what was over there. Now when it calls the G function, which runs the generator recursively on the context, yeah, now we can see it's ran the generator correctly and the sentence looks more Englishy. And again, this is very simple. Like we'll make it more complicated. Like in the demo, we can do like French and English output if you want, and you can choose. So I'm going to stop here, and in the future, in the next video, we're going to do cool stuff with the generators. We're going to take this "who are the players," and instead of have it just paraphrase "who are the players," we're going to have it list who the players actually are. And it'll be really easy to do and very cool. And then we're going to do some extra cool stuff with that too, around mood or people's feelings, which usually you don't get in computer land. So I'll save that for a part 2 video. And